Hey, in this video we'll be talking about data transfer protocols for networked multiplayer games. So, a protocol is just a convention. We need conventions in order to communicate in any sense. It's no different for computers. For example, we all agree on what the word cheeseburger means, but to put this into a form more like what a computer would use, when I ask you for a cheeseburger, you hear the sounds coming out of me, which you interpret as a message that I intend to send to you. You then parse these sounds into an agreed upon sentence structure, and you analyze the structure, maybe automatically, you don't even notice it sometimes, and you analyze the specific words for my exact meaning. If a computer sent a bunch of ones and zeros to another computer, it would be meaningless. It'd just be a bunch of garbage. Unless they have a common protocol for sending and receiving those messages and interpreting what they mean. So, let's talk about a couple of common protocols and how they deal with packets of data that are sent between computers. So, there's UDP. UDP is user datagram protocol, but nobody ever uses that. They just say UDP. So UDP is simple to understand. Your computer sends a one-way message to another computer, and that's about it. This is unreliable in the sense that the message might get lost along the way. Oops, it's gone, and there's no way to really detect that. If the network goes down, if you lose network access at any point along the way, for example, this could be a have to bounce off of several other computers in order to get to the other one. So like one of these might be your direct connection to your ISP, your internet service provider, and they might have to route this information through different parts of the wider network in order to get to the destination. If any one of those links fails, you could lose that message. So that's unreliable. Messages with UDP might also be slowed down depending on how they're relayed through the network. There might be multiple paths, and maybe one path is quicker than the other, and some of your messages might take one path, some of them might take another path. Who knows what's going on with your network? But depending on how they're relayed, some of those messages might arrive out of order, and UDP does not have a way to detect that either. However, latency is minimal. By that I mean that there's nothing in this protocol that would cause the message to be slowed down inherently. Latency is that time it takes for a message that's sent to be received on the other end. So you want that in a game to be as low as possible. If you're okay with sometimes losing messages and sometimes receiving them in the wrong order, but you get the advantage of having low latency, then UDP is great, a great protocol. So the other protocol we'll talk about is TCP. So TCP is often paired with IP, Internet Protocol, because it is widely used on the internet to reliably send messages. You don't want part of a web page because some of the messages got lost. So TCP is transmission control. Oops, let me make a T there. Protocol. All right, TCP. And TCP is very common. It is reliable. And messages come in order. So those are big advantages over UDP. With TCP, your computer has to chop up the message into chunks, and it assigns an ordered value for each of those chunks to ensure that it can send those chunks reliably, ensure that there are no errors on the other end when it receives this message, and to be sure that the message is received in the first place. The receiving computer, it sends an acknowledgement to say that, yeah, I got the message, or I got this piece of the message, so that the sending machine knows that it can continue sending the rest of the message. Each packet is numbered, so if the receiver detects a skipped packet, it can acknowledge the last packet that it received again, and the sender knows that something was probably lost and that it has to go back and restart sending that data again. That can be wonderful for reliability, but it means that it kind of slows things down. It increases latency just as part of the protocol. The same kind of mechanism makes sure that all the data is reconstructed in order. So TCP does a great job being reliable, doing things in order, because you have your messages sent, an acknowledgement is sent back, and this kind of two-way communication is making sure that nothing is lost in that transmission. But that takes additional time in order to ensure that that is true. When you're using, say, UDP, our non-reliable communication, you could add reliability to it by sending more messages back and forth. You could add a timestamp or something similar in order to make sure that you reassemble messages in order. And a lot of applications, a lot of games do that. But those happen at the application level, whereas TCP does it at the transport level, which technically means that doing it in UDP is going to be a little less efficient, but it's still very useful to have that flexibility. With TCP, you cannot remove reliability or remove the in order of the packets in order to improve the latency. You can't go backwards. So we have both. They're both tools, UDP and TCP, and the choice of which to use depends on the kind of data that you're sending and your needs for your program. So for an example, position data in a turn-based strategy game should be reliable. It should be sent reliably. Every single client must have the correct positions for the game to work right. It would really stink if you had a chess game and the chess pieces were in different places on different computers. That would be really hard to play consistently. That needs to be reliably communicated. That's a good job for TCP. For something like an MMO, massively multiplayer online game, position might not be really that important. Say you just send a whole bunch of position updates. Update your position several times a second. So just tell everybody where you are several times a second. It'd be totally fine if some of those updates are lost. The players, they won't really notice that there's any problem. They won't notice different positions on different clients unless there's a serious network problem. And such a problem, like a disconnection, would affect any protocol. So that's not really a big deal. So position in an MMO is a pretty solid candidate for UDP. To be clear, though, a single application can use both TCP and UDP for different kinds of data. So use the one that makes sense for you. Well, that's the gist for those two most common network communication protocols. When you get to choose, you should now have a little better sense of which one is the right one for you. All right, see you in the next video.